Well, hello, everyone, and welcome to today's National Board of Public Health Examiners Webinar Wednesday. My name is Ashley Mueller, and I'm the Manager of Educational Programs at MBPHE. So thank you for being here for today's topic, Public Health Microbiology in the 21st Century Under the Landscape of Changing Climate, presented by Dr. Aliyar Cyrus Fouladkhah. So Dr. Fouladkhah is a graduate of the Yale School of Public Health for a degree track in applied biostatistics and epidemiology, a graduate certification in food and drug regulatory affairs, and certificate in climate change and human health. He is currently a tenured associate professor at Tennessee State University and the founding director of Public Health Microbiology Foundation in Nashville. So this is very fitting topic for you to be presenting on. So with that, I also would just let you know the Q&A is open as well as the chat for you to be able to interact with yourselves. If you have any questions for our presenter, you can put them in the Q&A and we will be answering those at the end of the presentation. So with that, I'm going to turn over control to Dr. Fouladkhah.
Thank you, Ms. Ashley, for the kind introduction and also for your leadership in National Board of Public Health Examiner and for this wonderful seminar series. Obviously, this presentation is very close to my heart, and for the next 1 hour, I'm enthusiastically sharing some information with wonderful audiences in this webinar. So before we start, I would like to dedicate this presentation. May I please ask if you guys can see my slides, Ms. Ashley? Okay, perfect. Thank you. I would like to dedicate this presentation to someone very special. Obviously, my daughter was born exactly 6 months ago. Certainly being her father is the greatest honor in my life. But this presentation is dedicated to her and also everyone from her generation. So I decided to divide my presentation into 3 sections. The first section is a very brief section about overviews of my program, just by the way of introduction. The second section is talking about the impact of climate change from all over the world. I would say the second section is relatively light content, about 20 minutes. And the most technical information is towards the end of the presentation, the last half under the third section of the presentation. As Ms. Ashley was kind enough to share, I spent most of my adult life in the beautiful state of Colorado. I received 3 degrees there, and between my degrees, I had a chance to work with these companies. And then I had a chance to go to New Haven, Connecticut to receive additional training in epidemiology, regulatory affairs, and climate change. And about 10 years ago, more or less 9.5 years ago, I came to Tennessee in Nashville, Tennessee State University, and I started the Public Health Microbiology program. All the information that I discuss is on the website of our program, and these are some of the funding that is supporting activities of our program. Teaching faculty, and in addition to that, I'm grateful that other nations give me the opportunity to go to their country for holding workshop. These are some of the countries, 15 programs, international global health programs that I've held recent years. I also run a research program. We are talking about bacterial infectious diseases today. Many of the information that we discuss comes from the activities that the greatest students do in our program. And finally, my foundation is supporting entrepreneurs from all over the country. Around half of the entrepreneurs we have supported, 47% are women-owned businesses, and 57% of those are startup companies. With that brief introduction, we are going to go to the second part of the presentation. Obviously, some of the information are provided by this great institution that is listed on the slide, and I'm very grateful for the important information that they have provided as well. As we all know, obviously, this is our beautiful planet. And as we all know, this beautiful planet is surrounded by a relatively thin layer of air. It's only 60 miles. And unfortunately, as we all know, we are not treating that layer very kindly. In a typical day, we are dumping 110 million tons of greenhouse gases. And obviously, as we all know, these greenhouse gases have heat trapping properties. And because they trap additional heat, unfortunately, the life as we know it is changing drastically, especially in recent years and in the last 2 decades. These are the main sources of greenhouse gases. Maybe some of you guys don't like this slide. You like evidence-based information. So I borrowed this slide from Mr. Gates Foundation. And this slide summarizes the greenhouse gases. About 20% of it comes directly from the food that we consume. But it's worth mentioning that another 30% comes from manufacturing. An important part of that 30% is obviously our food as well in food industries when they are processing the foods. Same thing for electricity and transportation. So the current lifestyle, the current food that we are consuming is a major contributor to the greenhouse gases. And this slide shows the amount of greenhouse gases that we have generated in recent years. As you can see, it's pretty much the generation of parents and our grandparents that has caused major changes in our climates. And as we all know, Earth does not produce its own energy. We get all the energy from the sun. We send most of it back to the atmosphere, and a small portion of it we recapture because of the thin layer that we have. And as we all know, we are dumping more and more greenhouse gases, so we are capturing more and more extra energy every day. But how can we put that into perspective? How much extra energy are we capturing in a typical day? To put that into perspective, obviously, we all know that this is the end of the World War II. Massive amount of energy was released in few seconds. If we multiply that amount of energy by 600,000 times, again, if we multiply that massive amount of energy by 600,000 times, this is the amount of extra energy that we are capturing in a typical day. So day after day, 600 times more than the atomic bomb at the end of the World War we are capturing on the surface of Earth. And because of that, unfortunately, we are seeing all-time high temperature all over the country, all over the world. And this is the data pretty much from the 21st century. Most of our undergraduate students are born, obviously, after year 2000 and 2002. Within their lifetime, year after year, we are experiencing the hottest temperature on record. And the last 7 years, they were hottest years in the record as well. And this is an important number. Let's please remember this number, the 8-degree increase. Obviously, when it goes to impact of climate change, the southern we go on the planet Earth, the impacts are going to be more serious. And the same thing in this country, the southern part of the United States are going to be affected by greater extent. So southern part of the US are expected to be 8 degrees Fahrenheit warmer. And among 100 counties that are prone to climate change, 97 of those counties are located in the south. And as we further go south in the world, we are seeing more challenges. These countries, obviously, they are seeing their all-time high temperature. And obviously, in certain parts of the world, in South America, they are expected to see temperatures rising by 6.7 degrees, and in Central America by 4 degrees. And again, these two numbers are extremely important numbers. I would suggest we keep these numbers, please, in mind, because we are going to visit these numbers very soon. And some countries, about 90% of their population are going to be affected by climate change. Obviously, these are the countries that they are struggling with some of the commerce and economy, and we are getting a lot of immigrants from those nations. And within our lifetime, we are expected to see 90% of their population to be affected further by climate change. This slide is from beautiful state of California. Unfortunately, because of the massive amount of energy that we are capturing, we are seeing temperatures as high as 121 degrees. Obviously, it's not just about the heat. California is the breadbasket of the country. And unfortunately, we are seeing extreme weather events, extreme drought in 78% of that region. And obviously, that is an important region for the country and for the world because they are major food producer for the nation. And this slide is obviously from beautiful country of France. They are seeing their all-time high temperature in that country as well. This is from beautiful country of Ghana. They are seeing temperatures above 110 degrees in that country. A country like Canada, no one is expecting to see death associated with heat waves. Unfortunately, they are seeing as high as 90 people dying in that country, in one province of that country, because of extreme weather events. And it's not just affecting, obviously, the humans, it's affecting the animals and the animal that we are consuming as food as well. You can see one extreme weather episode, significant amount of wildlife and seafood in that country were affected as well. Same thing in certain parts of Asia, they are seeing temperatures as high as 105 degrees the nation. This is one of my favorite photos. Even the infrastructure in Europe is not ready for climate change. As you can see, this is a recycling truck, and because of the extreme heat, it is sinking in the road. And obviously countries like India, they are seeing temperatures as high as 124 degrees. Among all the countries in the world, perhaps Australia is affected greatest by climate change. They are seeing all-time high temperature, and at some point, the average temperature in Australia is even higher than the African continent. And obviously, as we can see in this slide, these massive amounts of energy that we are capturing every day translates to loss of ice caps in different regions of the world. And we are unfortunately seeing extreme weather events like the one that we saw in Puerto Rico. In one extreme weather event, some 3,000 people were affected. And this is from beautiful country of Philippines. When I see these photos, the first thing that comes to my mind is environmental justice. Obviously, this is a small country, a small economy. They are not making that much greenhouse gases. This is in part responsibility of other countries, especially those countries that are producing and consuming a lot of fossil fuel gas and greenhouse gases. Obviously, those actions will lead to consequences in some smaller economies. Same thing for country called Maldives. They are losing significant amount of their country, their lands, their economy. This heartwarming photo is from a beautiful state of Texas. And obviously, we are expected to see more extreme weather events like the one that we saw in that state. But some of us maybe are thinking these extreme weather events were happening anyway. How can we link those to climate change and the greenhouse gases that we are generating? So just about 100 years ago, not a long time ago, the extreme weather events similar to the one that we saw in Texas, we would see that once every 500 years. Because of the changes in our climate, we are seeing it now once every 25 years. And within our lifetime, by the time my daughter goes to the college, we are going to see that once every 5 years, obviously. So 100 times more extreme weather event compared to 100 years ago. And obviously these photos are from the beautiful state that I'm currently living from, a state of Tennessee, and we don't need to go that far. This is our own research infrastructure. Not a long time ago, I think it was 3 years ago, our entire significant section of our research infrastructure were impacted by the climate change. And this is the area that I park my car every day before going to office. Even those areas were affected by this climate change. So overall, because of the massive amount of energy that we are capturing every day, we are expected to see, as we all know, extreme weather events, storms, floods, mudslides, and all types of extreme weather events. In parts of the country like Puerto Rico is ranked #1 in the world when it goes to climate challenges and climate crisis. And this is not about only high temperatures and extreme heat waves. Obviously, significant portion of the GDP of some countries, especially the further south, is going to be impacted by climate change. Close to 1/3 of the GDP of this country, as an example, will be impacted. And unfortunately, we are seeing extreme drought events. This photo is from beautiful country of Zimbabwe in Southern Africa. As you may know, this country is neighbor with the country of South Africa, and I had a chance to have a workshop there in the Cape Town region. That is a highly developed region in Africa. Even in their capital, in a relatively nice hotel, they had a sign in their bathroom saying that please do not use the bathtubs because they don't have sufficient water. So if they are seeing challenges with water in the capital of South Africa, in Cape Town, imagine what is going on in other regions in Africa, especially I've seen some studies from eastern part of Africa that they are seeing major challenges associated with water. And this beautiful slide is from beautiful country of China. And as we are going to talk about, China is already having major food security challenges, and they are seeing extreme weather events and droughts in their nation as well. One extreme weather event, more than 2.5 million people were affected. Obviously, the entire population of Tennessee, I believe, is close to 6 to 7 million. Entire population of Nashville is less than the amount of people who were affected only in one extreme weather event. And in India, they are seeing temperatures and droughts that they have never seen in 140 years. This is the one that concerns me the most. In Brazil, obviously, just like California, that is the breadbasket of the country, South America is the breadbasket of the world, as we are going to see that. And unfortunately, they are seeing these challenges as well. Even in Europe, one extreme weather event, they have lost close to $4 billion of commodities in their country. And this is one of my favorite slides, obviously. Beautiful country of Switzerland. You can see they are using their army to deliver water for their agriculture to ensure that they can flourish under the landscape of climate change. And this is beautiful country of France. And as we can see, they are losing arable land. And once they lose it, obviously it would be very difficult to get these lands back for agriculture purposes. And this is beautiful state of New Mexico. I had a student from New Mexico, and when I was talking about it, she was saying the extent of damage is much more than what is stated in the slides. It's just one extreme weather event. They lost 50, unfortunately, thousands of beautiful natural environments that they have. And this is obviously very personal. I used to hike in Colorado as a college student. Many of the hiking trails that I was hiking, they are not available. So I can't take my daughter there anymore because of the wildfire. The season has grown by 105 days compared to 1940s. And obviously California, 14,000 homes, one extreme weather effect were affected by one extreme weather effect. And this is perhaps my most favorite slide of this section. I think it's very symbolic. And you can see the previous generation, they are enjoying their time. And in the background, this is my generation or my daughter generation who are going to suffer from consequences of the climate change. And climate change has some other major impacts in the world as well. This gentleman, as you can see, he's saying he had 400 acres of wheat in a small country of Syria, and now it's all desert. He's not alone. Close to 1.5 million people in that small country had to migrate internally or externally because of the climate change issues. And that was the main reason that country experienced a major civil war that lasted for more than 10 years in that country. And obviously, so things like major economical and political changes in nation could be directly linked to greenhouse gases as well. And if we all go, this is another favorite slide of mine. If we all go to the beautiful and iconic building in the New York, in the United Nations, there is a very iconic gate, obviously, when we are entering. This poem is written there. The poem is written more than 800 years ago. And President Obama even used that several times in his presentations and in his speeches. I'm going to read only the last two lines of that poem. It says, if you have no sympathy for human pain, the name of human you cannot retain. I think it's very true. Unfortunately, because of climate change, many regions of the world are not going to be livable anymore. And if we are concerned about immigration now, we are going to see a major increase in immigration because of the climate change. As an example, this is somewhere in Asia. They are seeing temperatures as high as 165 degrees. How hot is this? How can we put this into perspective? So if we go and purchase, let's say we want to make a very healthy, very delicious meal. If we purchase ground turkey and make a patty and make a burger with it, if we cook it to internal temperature of 165 degrees, according to USDA guideline, that product is safe to eat. They are seeing that type of temperature outside. Imagine what it's doing to their economy, agriculture, migration of birds, wildlife. Obviously, because of this, some studies are saying that by the end of this century, we are expected to see 1 billion immigrants. Obviously, this is going to be a challenge for all countries in the world, and obviously countries would need to come up with a solution to come up for this major challenge that we are going to face. This is perhaps going to be the most important slide of my presentation. In this slide, on the top, on the green side, we are seeing countries that they can make extra food for themselves. And in the bottom, we are seeing nations and regions of the world that they have food deficits. And then the slide shows from 1965 to 2019. So from left to right, we can see from about 50 years ago, a little bit more than 50 years ago, to 1920s. On the right side of the graph, as you can see, like in Asia, countries like China, they had food security issues back in 1965, and that food security challenges are growing as their economy is booming, as their middle-class population is getting larger and larger. Obviously, they are struggling to produce sufficient energy. Even as you can see, Western Europe, they had food deficiency issues and still have parts of Asia, parts of Africa. And I think it's fair to say United States and South America are the breadbasket of the world. Some former Soviet Union countries, like beautiful country of Republic of Georgia, beautiful country of Ukraine, to some extent, they were able to increase their production. And Australia, despite all the challenges, challenges associated with climate change, they were able to slightly increase their output. But I think it's fair to say the agriculture and food industry in the United States and South America is feeding the world, and they are breadbasket of the world. Unfortunately, do you guys remember? I requested we remember some numbers earlier in the presentation. Now we are visiting those numbers. Only 1 degree increase in the climate, we are expected to lose efficiency of these 4 crops. And these 4 crops are extremely important because 2/3 of the world calorie are coming from these 4 crops. I'm sure you all remember some regions of the world are going to be 4 degrees, 6 degrees warmer. So we are just talking about 1 degree increase. So obviously it's not about just extreme weather impact. It's going to be about food security issues as well. As an example, in the beautiful state of Georgia, our neighboring state, they are expected to reduce 34% efficiency of soy and 46% efficiency of their corn commodities within our lifetime by 2050. And climate change has other major impacts on the environment. It's not about the plant food. Obviously, it's going to impact the animal health as well. And it's worth mentioning that close to 60% of all the infections that we catch comes from the animals. And when it goes to new infections, 75% of those are coming from animals. A perfect example is if we go to the state of Florida, they don't have a freezing cycle, they don't have a frost cycle, so their soil is typically contaminated with parasitic agents, and these animals could catch parasitic agents because they have direct contact with soil. But obviously, in our state, in Tennessee, we have a frost cycle in the winter time. Because of the freezing of the soil, we can eliminate most of the parasitic agents. So we don't have those issues in the state of Tennessee. But as the climate is getting warmer, if we lose our frost season, then we are going to have those parasitic agents emerging in Tennessee. Or vector-borne diseases like Zika virus. The vector can only survive in certain parts of the country, including Florida. But as our planet is getting warmer, other states may see emergence of those new infections as well. Then when it goes to our wildlife, certain species are extremely sensitive to climate change. This majestic animal, obviously, when the temperature is high, then the eggs are hatching, they're all female. And in Florida, in Australia, in certain parts of the world, 99% of the turtles that are hatching, they're only female. So obviously, that creates a challenge for the next generation of these animals. And then if we go back to previous slides, as we all know, coral reefs, a very small portion of the oceans are covered by coral reef, less than around 0.1%. But about 25% of life in the oceans are surrounding those coral reef. In a sense, we can think of it like a jungle for the oceans. A small amount of the oceans is covered by coral reef, but most of the biodiversities are surrounding those areas. Unfortunately, in some beautiful countries like Jamaica, they have lost 85% of their coral reef. So they are losing significant amount of biodiversity, and they are doing obviously wonderful programs. They are trying to revive the coral reefs in that country. And then other challenges, obviously, could be associated with allergens and allergies. At current time, we are seeing around 8 cubic meter of pollen released in a typical day, and within the next 20 years, we are going to see nearly 3 times more. So I think it's fair to say allergies and allergens will be augmented under the landscape of climate change. This is another slide that I really like. Unfortunately, by the end of the century, it is expected that we are going to lose 50% of biodiversity, 50% of all the species. And maybe some of us are thinking the age of Earth is 4.5 billion years. And for the last 3.5 billion years, so many species came and so many species go. Why should we be worried about other species? And obviously, the answer, as many of us know, these species, obviously, they are wealth of knowledge when it goes to bioactive compounds, pathways. As we are learning more about them, we are learning more about ourselves and our own health. And an easy and a perfect example is, as we all know, in this country, the probability of developing hypertension is close to 90%, as we can see in this slide from CDC. So the medication that people use to control their hypertension is one of the most important medication in this country. It's saving so many lives in a typical day because it's a very common problem, obviously. And that ACE inhibitor medication, the first time it was isolated from a venom of a snake. So I think it's fair to say that it's not about their health, it's about our own health as well. Our health is linked to their health as well. With that slide, I think we can conclude the second part of the presentation, and the last 30 minutes or so, we are going to talk about public health microbiology under the landscape of climate change. So more technical information we are going to discuss in this section. I saw already we had one wonderful comment in the chat. Hopefully we can discuss all the great information that you have in mind at the end of the webinar as well. So with that being said, as we all know, one of the major differences between bacteria and viruses is if I'm sick with the virus, if I cough it on a surface, typically it doesn't survive for an extended amount of time. In most cases, it's few hours depending on the nature of the surface, or less than 1 day. In contrast, if I have bacteria on a surface, if the environment is favorable for the bacteria, every 20 minutes, the bacteria can replicate. So one mother cell become 2 daughter cells. And in short amount of time, in about 12 hours, one bacteria could become more than 68 billion microorganisms. And as these microbes are replicating themselves, replicating their genetic material, occasionally they make mistakes. And most of the times they don't survive the mistakes. But in rare cases, the surviving microorganism has some unique characteristics. So if we look at this 68 billion microorganism that were created from one microbial cell in less than 12 hours, there is a very good chance that we can find a microbe with new characteristics. So we don't need to do anything just on their own. Microbes are constantly evolving, and that's why within our lifetime, we are expected to see new challenges associated with microbial pathogen. In short, they call this vertical gene transfer mechanism, as a mother cell gives the genetic material to the next generation. Because of occasional mistake, we are seeing new microbial challenges. Another mechanism, in short, all of them, they call them horizontal gene transfer mechanism. Microbes can use these sophisticated mechanism to come up, to move towards diversity and fitness. Let's say, just as an example, if some of us might have some amazing skills, maybe we know several languages, maybe we know how to play musical instruments, maybe we have excellent athletic ability. Obviously, those are the characteristics that it took us many years to get, and we cannot share that with each other. I cannot come and get a characteristic from another person. But in microbial communities, once a microbe has a unique characteristics, they can easily exchange that with each other. Let's say a microbe has a plasmid, a small piece of DNA that makes the microbe resistant to antibiotics. By a mechanism called conjugation, they can easily exchange that. You could think of it like tools for their toolboxes. One E. coli, one salmonella, they can exchange this genetic material with each other. And another mechanism is called transduction. Obviously, relatively speaking, a typical bacteria and a typical virus, obviously there are differences in size between the bacteria as well, but comparing the size, viruses are nearly 20 times smaller than a typical bacteria. So just to put it into perspective, if viruses are a little smart cards, these bacteria are like a larger truck. So obviously these viruses could infect the bacteria in nature, and as they are going from one bacteria to the other, they can transfer genetic material. They call this transduction. And once bacteria die, obviously their genetic material or like tools in their toolbox will be in the environment, and other bacteria could come and pick those things up. So these are other mechanisms, other unique mechanisms that bacteria use for moving towards diversity. We come up with treatment, with solution, and they are constantly evolving using these mechanisms. Another really complex capability of bacteria is biofilm formation. For viruses, they die on a surface in short amount of time. Bacteria, not only they don't die, but they can make these complex structures. They can make almost like a small, you can think of it like a small city for themselves. They can make it on biotic surfaces and abiotic surfaces. And a perfect example is, no matter how clean and careful we are, every 6 months we have to go to a dentist, and in dentist office they physically remove the biofilm from the surface of our teeth, because once microbes create biofilm, it would be very difficult to eliminate them from a surface. And to show the importance of biofilm, I'm sharing the PhD research of a wonderful student in my program, Dr. Allison. She is now an assistant, a faculty member herself in Tennessee State University. In her research, here we can see this is on a log scale. Perhaps this is the only slide that I have, only a few slides about scientific data that I have. So in this slide is on a log scale. So if we go from 5 to 4 log, it's 90% reduction. 5 to 3 is 99% reduction. As we can see, when bacteria are in planktonic form, when they didn't have a chance to form biofilm, we put a nasty microorganism on the surface. This is the Chronobacter sakazaki. This is the bacteria that caused the infant formula shortage not a long time ago in this country. We see once we have this nasty bacteria on the surface, we tested a very common antimicrobial. They use it in hospitals, in veterinary clinics, in the industry, in manufacturing, and we saw that close to 99.9% of the bacteria were eliminated. Obviously, that's a very good news. We were able to control a nasty bacteria on a surface with a common antimicrobial. But when we waited 7 days, you can see now we are on the biofilm side. These microbes were able to make a complex biofilm, and when we use the same treatments, we see major number of microorganisms are surviving. And the same thing after 2 weeks, as the bacteria were making more complex biofilm, it was more difficult to eliminate them from the surface. Obviously, that shows the importance of bacterial biofilms. And finally, these microorganisms, they have unique capabilities to some extent. They can communicate with each other. They call this quorum sensing. By small molecules, they can communicate with each other. A perfect example is shigatoxin producing E. coli. As you know, this is a bacteria that is primarily associated with the meat industry, undercooked burgers. Let's say I have an infection with this bacteria. E. coli is circulating in my blood, shigatoxin producing E. coli. If I go to a healthcare facility and they give me antibiotics for this specific microorganism, we are not talking about all bacteria, but this specific microorganism has great quorum sensing capability. So they sense the antibiotic in the blood, and collectively their response by quorum sensing is to make more and more shigatoxin. So if I take antibiotics, it could be potentially lethal for me because the microorganism could make more and more shigatoxin. So for certain infections, certain bacterial infections, including shigatoxin producing E. coli, sometimes they don't do any treatment. They are hoping the immune system of the patient could eliminate the microorganism. So because of all these complexities that we discussed, because of the vertical gene transfer mechanism, horizontal gene transfer mechanism, biofilm formation, and quorum sensing, unfortunately, it is estimated that we only know around 1% of microbial community. And infectious diseases obviously is a moving target. Within our lifetime, we are expected to see new challenges associated with these microorganisms. I think it's important to mention that our age on Earth is about 100 to 300,000 years. These bacteria have been around for close to 3.5 billion years. So obviously we are very vulnerable, we are very sensitive to these infections. So when it goes to the commodities, to the food that we consume, in a typical year, around 3,000,000 people die because of the bacterial infection from our food. In the first glance, obviously even 1% is tragedy, but in the first glance, compared to other diseases like cardiovascular diseases and cancer, it looks like a very modest number. But in fact, in a typical year, 1.7 million people are diagnosed with sepsis, as many of us know. Once we get the infection, sometimes we may die because of the bacteria itself. Sometimes our own immune system is overreacting and causes sepsis. So in a typical year, 300,000 people die because of sepsis, and 1.7 million people in this country are diagnosed with sepsis. So obviously these 300,000 cases, they don't count it as bacterial infection, but there is a very good chance that most of them or many of them are started as foodborne infection. So the true number is much higher than 77, much higher than 3,000 people. And as we all know, 30% of the population are very sensitive to these infections from food. And the cost of these infections to the economy in this country is $77 billion. And to put it into perspective, in Caribbean region, as we know, as many of us know, there are more than 200 islands, many countries. And among those, one of the most successful countries, the beautiful country of Jamaica. Year after year, their economy is growing, and obviously they have tourism and mining, very successful nation. In that country, their entire GDP is close to 15 billion, 15 billion. So only foodborne diseases in this country, nearly 5 times, 6 times more than the entire GDP of a successful nation. In the first glance, if we take a look at these infections, it looks like viruses, foodborne viruses are very important. These are classic epidemiological data: illness, hospitalization, and death. But one of the major differences between foodborne bacteria, we are not talking about respiratory bacteria, but only when it goes to foodborne bacteria, most of them, they are self-limiting in nature. In contrast, we catch those viruses and we can, without any treatment, we can fully recover from them. But unfortunately, the bacteria that we discussed earlier, not only they cause infection, sometimes we survive the infection, but for years to come, we are going to have major health complications like Guillain-Barré, associated with Campylobacter and Salmonella, or hemolytic uremic syndrome. This is a potentially kidney complication when we are exposed to Shiga toxin producing E. coli. So public health professionals, they consider all these complexities. They look at classic epidemiological data, death, hospitalization, and illness, and also number of years that we lose associated with disability with these infections. So they calculate an index called disability adjusted life year. And based on that, if we rank the microorganism, it looks like 62% of the public health burden of these infections from the food that we consume are associated with bacteria, followed by 29% of parasitic agents and 9% of viral disease. Obviously, we are hearing a lot about viral diseases these days, but I think it's important to consider parasitic agents and bacterial agents. Obviously, they have the lion's share when it goes to the public health of these infections. Most of these infectious diseases from our food, when it goes to number of illness, we catch them from fresh produce. And it makes sense. If I'm purchasing some strawberry, some fresh produce, I'm bringing it home. If it is contaminated in the farm, I don't do that much at home. I just lightly rinse them and consume them. So most of the illness are associated with fresh produce, but most of the deaths are associated with the meat product. It makes sense. They have more nitrogen and they are more nutritious, so bacteria could multiply there. And typically we are exposed to higher number of microorganisms when it goes to meat and poultry products, so it could be more lethal. These data are from CDC. We had a wonderful intern from California who worked on this data, and it shows the number of outbreaks associated with our food in the last 20 years or so. On the top, we can see the nationwide outbreaks. And then I just put 3 states. We have data for more states, but we just put 3 states for the comparison. In the first glance, it looks like Tennessee, Maryland, and California, we are all having the same number or similar number of foodborne outbreak. But obviously, it's important to consider that the population is different. Tennessee has around 7 million population. California has more than 40 million. So if we adjust for population, we can see we have nearly 5 or 6 times more than California when it goes to number of outbreaks. Obviously, that shows the importance of the great work that we do in the public health agencies, and also it shows the importance of policies and regulations for controlling these infections. We talk about foodborne diseases. Now for some time, we are going to discuss waterborne diseases. Obviously, as you guys remember, the burden of foodborne diseases was around 3,000. The burden of waterborne diseases in this country is nearly twice as much, but the cost to economy is much smaller. This work is completed by the postdoctoral fellow in our program. He is now an assistant professor in the state of Georgia himself. And in his study, he's showing that he looked at 3 microorganisms: Listeria monocytogenes, Shiga toxin-producing E. coli, and non-typhoidal Salmonella. And he looked at 3 different temperatures. He saw that once the surface water is contaminated with these 3 bacteria, up to 28 days, almost 1 month, these bacteria were able to survive. So even in a low nutrient environment like surface water, they can survive at 5 degrees. Obviously, that is a very cold day. 25 degrees is a room temperature, and 37 is close to human body temperature. So at different ranges of temperature, these bacteria could survive at least for 1 month without major source of nutrients. And not only they survived, but they were able to make this complex biofilm structure. And because of this capability, obviously, when it goes to extreme weather events, most of the waterborne diseases are associated with extreme weather events. Obviously, these waters could be highly contaminated with microbial pathogen, and they could survive there for extended amount of time. Another bacteria that I think it's worth mentioning is non-typhoidal Salmonella. As we know, in a typical year in this country, unfortunately, close to 1 million people are estimated to catch non-typhoidal Salmonella. And that's precisely the reason that we put our fridges at 41 degrees Fahrenheit, because this bacteria at higher temperature could multiply, but at lower temperature in our refrigerator, this bacteria cannot multiply. This is one of our new studies with colleagues in Yale School of Public Health, relatively new study, and Vanderbilt Engineering. And in this study, we show that if our climate is getting warmer only for 1 degree, we are expected to see as high as 100,000 extra cases of Salmonella in this country, and as high as 5,000 additional deaths globally. So this is only for 1 degree. Unfortunately, within our lifetime, by 2040, our planet is expected to be 1.5 degrees. And by the end of the century, our planet is expected to be 4.8 degrees warmer. Obviously, we won't be around to see that, but our kids and grandkids are going to see a world with infectious diseases as a major problem and a major concern for them. This is another bacteria of importance. This is Vibrio species associated with the seafood product. One genus has several species. One is Vibrio cholerae. We are all familiar with it. It is causing global health issues. And there are other species like Vibrio vulnificans that is causing challenges associated with the seafood industry. This is a bacteria that is halophilic in nature and like high salt environment. This is the current burden of Vibrio, current global burden of Vibrio. As we can see, some parts of the East Coast, some parts of the West Coast are affected by this pathogen. And if we look at the beautiful country of Ukraine in the Black Sea, as we can see, there is no challenges associated with this pathogen. Unfortunately, by the end of the century, this is the landscape just for this pathogen. We can see even in the beautiful country of Ukraine, in the Black Sea, and several regions of the world, this pathogen could become a re-emerging pathogen and cause global health and public health challenges. And obviously, it's affecting some of our most favorite foods, these seafoods. Maybe in the future, it becomes unsafe, even more unsafe to eat because of the changes in our climate. And obviously, we are already seeing the impacts of Vibrio-related illnesses in this country because of the climate change. Climate change obviously has other major impacts. We have only 10 minutes time. Obviously, we don't have time to discuss all these things in detail, but I think it's important to mention mycotoxins. As many of us know, once mold grow on a surface, like as we can see in the photo, once they establish their colony, they make secondary metabolites, and many of them are toxic to us, including aflatoxins. In general, they call all these toxins made by molds in commodities mycotoxins. Ochratoxin is another common toxin associated with the coffee. Obviously, I've held workshop in Central and South America. I know when it's coffee season, it's very cheap. They go and purchase a lot of coffee beans, but they don't have customer to sell them immediately. So they store them for extended period of time. And because of that, this ochratoxin could be associated with the coffee product. And as our planet is getting warmer, there are studies saying that we are going to see, unfortunately, more and more mycotoxins in our diet and in the food chain as well. And then obviously, entomology is a really important field of study. As we can see in this wonderful country of Kenya, they are seeing extra CO2 in the air. It is causing these insects to bloom. And as we can see in this image, they are causing major challenges for the agriculture in those countries. And this is beautiful country of Italy, some of their favorite food delicacies in those regions. I've never eaten something like this, but I can imagine this is a delicacy in Italy. It is affected by high temperatures associated with the climate change. And this is another example from Mexico all the way to Canada. Unfortunately, in one episode, it was affected by algal bloom. So during my presentation, I only talk about challenges and negative information. Just to finish the presentation on a positive note, I was curious to see who are the people who are interested in these information, who are really passionate about climate change. So we work with a company in the United Kingdom. We came up with a 8-week social media campaign. And so we shared this information and we followed their interaction with this information. And this is the result of that study. On this social media platform, obviously, recently they have changed the name. We were able to reach 42,000 people. Vast majority of them were men, but close to 40% of the women were interested in these topics. On Facebook, it was predominantly older men. We reached close to 31,000 individuals who reacted to this information within the 8-week campaign. But what gave me a lot of hope and optimism about future, when we created a website that was accessible for everyone in the world, we saw, first of all, men and women are equally interested. We reached more than 135,000 people, and we saw interest from all regions of the world, from Australia, Asia, Western and Eastern Europe, Africa, South America, and United States. And we primarily saw that kids who are in their 20s, even younger generation, as we can see, they are very passionate about this topic. That gave me a lot of hope, a lot of optimism. This is perhaps going to be the greatest challenges of our lifetime. And I think this is their responsibility to come up with solution for these challenges. So this is our beautiful planet, and it needs your help. Thank you so much for your time. Obviously, if you have any question, you are certainly welcome to email us. Many of the information that we discussed is going to be on our website as well. Once again, I would like to thank Ms. Ashley for her leadership in National Board of Public Health Examiners. She is a very busy person coming up with questions for the exams and doing this seminar. I'm very grateful to her. I really enjoy making this presentation for the wonderful audience. And if there are any questions, I'm enthusiastically available.
Yeah. So we have about 5 minutes. So if you have any questions, please put them in the chat and we'll answer them. I did see somebody earlier put a comment that said, I just read in the news that Florida legislators are sponsoring a bill to remove the mention of climate change from state laws and other areas of policy. Climate change clearly needs to remain a public health priority nationwide, especially in the southeast part of the United States.
What a remarkable comment. Yes, I agree, as we discussed, southern United States are going to be affected even in greater extent. And yes, hopefully the new generation, 18-year-old, 20-year-olds, they will choose politicians who are like-minded, who like the environment and support their agenda. I think soon they are going to be the largest block of the voters. So hopefully they can make major changes in the politics in their regions as well.
Yes, absolutely. Well, it doesn't look like we have any questions. So if you do have any questions, you did have up on the screen your email, so they can contact you directly. I just want to say thank you so much for your time. I've seen parts of this presentation before, and it's always fantastic to see such a great presentation on such an important topic. So thank you so much for your time today. And then everyone who is in the audience, I hope to see you next month for our next webinar Wednesday. Thank you.
Thank you.